probably before some more students join, let me uh, complete the last class program. So, which is already done. A little bit more like you have seen that there is a method called list that lists all the file names present in a directory by which the file object is created. If we want to know the file size and other details, we require the file objects. The file object will contain the file size and other details also if required. So that's why there is another method called list files present inside the file object. For example, yesterday's program, if we take a look into, so this is the actual program that we have written. So in the current working directory, you are trying to list all the file names, and because by using the arrays.sort, this particular thing, which is present inside java.util, you are trying to sort all the file names present in the files array of strings, which you get naturally by making a call onto the list method on the file object. And inside this, we are trying to what it is not to display the file name starting with a dot. How do you do that? By comparing the file name, whether the file name contains a dot in the beginning. So how do you do that? By just simply invoking string dot, that means yes dot starts with, followed by a dot. So that means all the file names starting with dot are not being printed, as simple as that. If you want to print all the file names ending with extension like Java or ending with extension like .c, that also we can actually do. Instead of starts with, you can say ends with. There is another method called ends with. So you can compare and then see whether those things are there or not. So that kind of stuff. So we can see very easily, for example, the same program, you want to display all the Java programs, right? You want to display all the Java programs. That means all the file names that end with .java. That end with .java means this not should not be there, right? So here, so you say you remove this particular thing, and then yes dot ends with here. So ends with means you say end, ends followed by the corresponding thing. So like this, s dot, if s dot ends with, followed by what? So ends with .java, for example. So that means if the file name is ending with .java, you are trying to print it. That means all the Java file names you are basically trying to print out. These things naturally, if you learn the Java properly, all the other string classes, file reader, file writer, that kind of stuff, you will naturally get all these ideas, right? So it's not a difficult thing at all. But the question is, you have to start learning the language concepts. Then, like any kind of small programs that are actually asked, you will be in a position to write them. So when you give like this now, as you can see, it is displaying all the Java programs. So is there anything like a .java also is there? Like we'll have to see whether is there anything like .java. There is a folder called .java folder. And that folder contains fonts and other details and all that. Anyhow, so apart from that, all our programs, whatever that we have actually written. So like this, you should be able to modify or make small changes to your program to get the actual objective, right? So apart from the file names, if you want to display the file size also, yesterday we have already seen tutorials point or some other thing and so on. So where there is a method on the file object, right? So then you can always display the corresponding thing and so on. So how do you know, like, what are the things that are there in the file object, what methods and all that you can get to know by just simply appropriately invoking uh, things like, you can see here, Java followed by file methods. So these are some of the methods that exist. Whether the file object that you have, is it possible for you to read the contents of it by using the can read method? It returns Boolean, true, false. So and so on. So there are so many things like if you want to delete a file, you can say by just simply saying file object dot delete. So essentially now from the file object, if you have the file object, to know what is the name of it, there is a method called get name. This we want. And also, like, if you want to find out what is the size of that, return the size of the file in bytes. So there is a method called length, right? These two we can get to know. So by just simply invoking these two methods, one is called as the length, the other one is called as the get name. So now we can go back to this particular thing, make small changes and display the file name along with the file size. So for example, now, so now we want to return file objects, not the string objects, because it's not the file names. You are going to get the file objects. So instead of a string array, we would like to have file objects here. File object is FILE. File array followed by files. Right? So like this we can specify. Now files is equal to f dot what? Not list. List means it only lists the file names. So there is another method called list files. So then, like, you are going to get all those things. So once you have got all of them, now there is no point in sorting this thing because the names are not there here. So, and then for each one of the file now, not for every file name, but instead what you are going to get is the file object. So for every file object, we will have to do it now. So files is file related stuff. So we say for every file. So that means file object F, for example, F colon. So that means every file object you are going to get it into F variable. Now what is to be done? You want to, let us say you want to display only the, like, all the file names to begin with, and after that we will see the other things, right? Let us say, let us display the file name as well as the file size. So in order to do that, particular thing, so we have system dot out dot printf. So file name as well as file size we want to display. File name is percentage yes, right? Percentage yes, file name. And after that, like some space, and then we will specify that file size. File size is naturally percentage D. And then a new line, right? Comma. So first file name. File name means what? We have the file object f dot. So we need to make a call onto that get name method. Get name. So this returns the file name. The other one now is f dot. You are interested now in file size also. So length. F dot length. Semicolon. So it's printing both the file name as well as the file name and going through all of them. So this is going to take care of each one of them, in fact, including the files and folders, if at all, if there are anything like that. And also file name starting with dot also, all those dotted things also you will get. It doesn't matter to begin with. Let us see. So we have saved that. Now you need to compile that. Compile this particular thing. Variable f is already defined in method main. Probably we have already used that. So one should be careful while doing that. File f is already there, right? So naturally this should be something different. F dot list files. So I can use this is FF, I will call it. Another F. I'm just going to use it. Here also you need to make a similar thing. Like this. So this is a small change that we have made. Then compile it again. And then run that. So when you run it, it's likely to run through several file names. So let us use a pipe symbol and then use less so that we can examine each one. So you can see now the file name is this .x screensaver. And the number of bytes, the file size is 14 bytes, extra 30, 75, and so on in that particular fashion. All of them happens to be starting with dot. So dot config and several other things in that particular fashion. So we can also see our own Java files here. Hi.java 133 bytes. List.java 287 bytes. MyCP.back backup file 723 bytes. Like this, you can actually do this. So in this, if you want to again restrict yourself to like what it is to display only the Java files and all that, you should be able to do that very easily, right? So by just simply saying here, you need to compare, right? By just simply saying if. So first you need to get the file name, and because Java and all that you are saying, ff dot get name. So you have now a string now. Get name means you got a string, and that string dot ends with followed by within quotes dot Java. So if it is ending with Java, only such files you would like to display. So ff dot get name returns a string. That string dot ends with Java returns true false kind of thing. And whenever it is true, so you want to display that. So this you can always have an indentation. So that's all. When you do like this now, so you're filtering. Like you can in fact use the other filter technique also and so on. I'm not going into those details because of your limited knowledge. I don't want to make things more complex. You're not giving me opportunity to go beyond the limits. Anyhow, so this is how you can compile it. And again, when you run this, now you don't have to, because it's going to display only the Java files. So you can see now .java 4096 bytes because it's a folder. Folder, you normally get this particular number, and these things are this. How do you know whether this is correct or not? So by just simply saying star.java. So using the standard ls-l also you are using. So Towers of Hanoi 2013 and 2013 here you can see. So rev.java 347 bytes, 347 bytes here also. Like this, you can also use the file objects in order to get some more details other than file name alone, right? So that's about the file object as far as our syllabus or whatever is concerned. If you have any questions on this, you can. Most of the times you don't ask anyhow, but it is my responsibility to remind you from time to time. So any questions so far? So no questions. So you're absolutely learning everything so fast. So no issue there. Let's move to the other things like. So now I will use one of the textbook that is there so that very quickly I can brush through and wind up the classes at the earliest possible thing. So anyhow, this particular thing. So if you want to declare constants and all that, you don't want any changes to happen, that kind of stuff. Java language allows. In fact, in C language also you have a keyword called const, C-O-N-S-T. So whenever in C language, for example, so when you say, big problem. So if you want to declare a constant, so you can just simply say int followed by, or standard thing is double, let us say double, and then pi value equal to, and you specify that 3.1415 whatever. This is how you declare in C language. So you are saying that pi is a variable, but its value should not be modified after initialization. Once you initialize this in the future, this thing, you will be using the value of the pi, and you will never make any changes. So the advantage of doing this is that whenever you require this kind of thing, you declare this as a constant. Then by mistake also, if you by mistake you try to change it in your program, the compiler will catch and then try to generate the syntax error saying that you have declared this as a constant, but you are using the variable pi in a situation where its value is likely to be changed. So that is how the languages will support. The same thing in Java, it is done by using the keyword called final. So the value of that is final. So that's how it is, something like that. So you say final. And after that, whatever declaration that you are already familiar, right? So for example, you say double, again pi equal to 3.1415. Maybe in case it is a static variable, right? In case pi is a static variable, you want that to be, then you will say static, right? If it is a non-static kind of thing, you can also say that. So in which case you don't use that. So most of the times, The constants are likely to be static variables. So you can say final static double pi equal to this. And in case you want to have the scope and all that, you can specify that. Public saying that yes, it is available to all the code. Public final static double pi equal to this. So this kind of this thing. So once you declare this as a variable, as a final kind of a variable, its value cannot be changed. Right? So this is one usage of it. The other things, so these things are also sometimes called as named constants. So here you can see final static double interest rate equal to 0.05. Right? So this is how one can actually use. Similarly, there is another way of declaring the named constants by using a keyword called enum, enumerated constants. Enumerated constants. Whenever you want to have a number of constants which have some specific meaning. For example, here he is talking about enum alignment. Enum followed by the name of the enumerated variable. Name of that is alignment. So within this curly brace, you only specify the constant names. You don't have to specify the values. So that is the beauty of it. So whenever you want to have a number of constants, right, that have some significance, so that each one of them should be initialized with a different value. Most of the time, they are likely to be initialized starting with 0 and all that. So enumerated constant, enum alignment, curly brace, left, right, center, curly brace, close. It's only a kind of what it is, a notation convenience that people normally use, all in capital letters, the names of the constants. This is a kind of a convention that people try to use, so that whenever you look at a variable having all the all in uppercase letters, that means you immediately understand, oh, maybe it is a constant kind of thing. So that kind of, so that's why it is. So this enum alignment, curly brace, all this is equivalent to actually, so almost, declaring in this particular fashion, public static final int, alignment left equal to 0 and all that. But in this case, so it actually treats this as if it is a class kind of thing. So in order to access this left constant, you have to use the dot notation. Alignment dot left is the constant name. Alignment dot right is another constant name. Alignment dot center is another constant name. Like this, you can specify any number of constants, like week names, month names. So such kind of things, normally we go for enumerated variables or enumerated constants. Similarly, fonts also. There are so many types of fonts like plain font or bold font, italic font. So even there also enumerated data type is actually used. It's going to be very handy in fact. So wherever you require a number of constants, you can go for enumerated data type. Right? So after this now, let's move to the interfaces and abstract classes. Interfaces and abstract classes. See, essentially, so far, like we have already in some of the earlier classes, we have created and we have been creating a classes. A class means most of the times we are indirectly talking about something called a concrete class. Concrete class means that a class that can be used to create the objects. The class can be used to create the objects. Any class that can be used to create the objects, such classes we call them as concrete classes. That means it has got all its implementation. all the methods inside the concrete class are already implemented. Their code is already there. What it means is that Java language supports or what it is creating a partial class probably, right? Not a full-fledged entity. And such classes we normally call them as abstract classes. Essentially, this we use in the designing stage. At the design stage, you don't implement everything. You only talk about the ideas, general ideas. I want to have so-and-so class having all these attributes and having all these methods with so-and-so signatures. So you only identify the methods and their signatures, but you don't write the actual code within the method. So such methods, we call them as abstract methods, right? So you can also have abstract methods. A method whose signature only is identified, but its implementation, the code of that particular method is still not written. So such methods, we call them as abstract methods. A class that is having at least one abstract method is called as an abstract class. Because as you know now, if the method is still not implemented or the code is still not written, naturally if you create a class object out of that and if we call that particular method, what to do? Still it is not known. So that is why a class having abstract method, right, cannot be used to create an object. Because by using the object, you want to call that particular method and the method is still not implemented. So that is why you can create objects only when all the methods are implemented within a class. And such a class, we call it as a concrete class. So sometimes at the design stage, you are going to design only the abstract classes so that, as some of you might be aware of, in the software industry, you will have designers, software designer. That is one job actually. Software developer, that is another job. The software designers are likely to design these abstract classes and all that. They decide about the overall, what are the various other classes that are required, the abstract methods that are there and so on, and give that task to the developers to complete the abstract methods that are written inside the abstract classes and all that. So developers will have the skill of writing the implementation of a code for certain methods whose signatures are already there, and what needs to be done is already there, and you will have to write the corresponding code. That is the entry level job. Whereas given a problem, a bigger problem, your user requirements and all that, out of that the designers will think about what are the important classes and the methods that are required in order to complete the project and all that. So they are going to come out with the list of classes, of which some of them might be abstract classes and all that, and all the method signatures, everything, and then pass it on, especially the abstract classes and interfaces, pass on those things to the developers so that the developers will complete the what it is concrete classes out of the interfaces or out of the abstract classes. How are you going to complete that? By implementing the corresponding interfaces. So there is a keyword called implements, right? So by using which you can try to implement the corresponding thing. So that is the general idea now. And with this background, let us actually let me open the book so that you can get into some more details. objects and classes, before which the fourth chapter is on subroutines. Objects and classes already, to some extent, you have already have inheritance and all that. GUI, arrays, exception handling, then this. Oh, somehow it's missing. Right. So it's there as a part of the objects and the classes itself. You can see 209 is the corresponding thing. So let me 5.7 will have to go 220 kind of thing. 5.6. Right. 5.6 only still. .7. Nested classes, interfaces, all this. Right. So this is the one. Interfaces, nested classes, and other details. So essentially, Java language doesn't support multiple inheritance directly. C++ supports that. Multiple inheritance means this particular thing. As you can see, class F is getting or is inheriting its properties from class D, E, and C. That means class F is extending D, E, and C, or C, D, and E, either way. So whereas here also class E is you are getting this out of A and B. So in the case of Java, if you see, you can actually use something like class name extends followed by, you can specify only one class. You can extend only one class in the case of Java language. Multiple inheritance is not supported. So, but they have thought about in a slightly different way, because this is going to make things more complex and all that. So that's why they have thought about. So D, C, D, E. So all these three cannot be inherited straight away. So such multiple inheritance is not allowed in Java. The designers of Java wanted to keep this very simple and all that. But multiple inheritance can be done in a slightly different way by using the concept called interfaces. You can actually implement multiple interfaces so that the behavior of multiple interfaces can be inherited to another class. So that is possible, right? So let us see first to begin with. So one by one, how you can actually do that, what is the syntax and all that. Syntax wise, if you see here, so public is anyhow, as usual, you know, public, protected, and private. So that meaning you are already familiar. But instead of class, you will say interface. And then interface name. Class name, interface name. Enum, enumerated name. So as simple as that. After that, a curly brace begins. And then within this now, you cannot implement any of the methods. You can only define the signatures. Right? So all the methods inside the interface by default, they are all abstract methods. Whereas you can have a class, abstract class, where some of the methods can be implemented and some methods can be declared as abstract class. Anyhow, so that also we will come later on. But here, as you can see, you are only declaring a signature of a method called draw, whose signature is public void draw of graphics G. Semicolon, curly brace close. So it's a very simple interface having one single method. Then how are you going to implement or how are you going to use this particular drawable interface? That can be done by using this kind of a syntax. Public class name, implements followed by interface name. After implements, you specify any interface name. Now, what do you mean by that? Public class line implements drawable. That means now you have to implement all the methods that are there inside the interface called drawable. So this is the stage where you are implementing. That means then the object created out of a line class can be used. You can create an object out of a line class because the method is already implemented. You can invoke the draw method and do whatever that you require and all that. So essentially you are delaying the implementation part. So the designers will develop the interfaces. The developers will implement the methods inside the interfaces by extending or by implementing those interfaces and create new classes out of that. Create new classes out of that. This is how you do it. Class name implements drawable. And inside this public void draw, you cannot change the signature. Remember that. You have to use the same signature. But you are going to implement or complete the code. Coding part is going to be completed. And later now you can create the line object by just simply saying like a line followed by L equal to new line of whatever. All that you can always do that. Right? So similarly, as you can see here, it is possible for you to implement more than one interface, but you can't extend more than one class. That is a restriction. So you can see here another example, a class name extends circle. Filled circle, you are creating a new circle called filled circle, which is a subclass of the superclass called circle. Circle, assume as if there is a class by name that, and you are creating another subclass out of that by using class filled circle, extend circle, and then implements drawable and fillable. So you assume that there is an interface called drawable interface and there is another interface called fillable interface. And probably each interface has got its own methods and all that. So this is allowed. Now inside this, now what is to be done? You must implement all the methods that are there in the drawable interface and also all the methods that are there in the fillable interface. And extend any other thing, whatever that you require. But implementing all the methods inside these things is very important to make this filled circle to be a concrete class, so that the objects can be created out of them and then actually move on along those lines as a part of it. But remember, because Java language separates the creation of the objects and the declaration of the objects. Both of them are separate here. For example, whenever you declare a variable, for example, when you say something like string yes, semicolon. So it's not creating any string object, remember that, right? There is only a variable by name, yes, there is no doubt, but nothing is created, nothing is allocated, no object is created so far. Yes is only a null object, basically. But you have declared this. How do you create the object? Only by using the new operator. Only by using the new operator. Or there might be something like a student, right? ST. So it only declares a variable called ST. And you can't use the object ST right now. It's not a full-fledged object at all. In order to make this to be an object, what do? You always use new followed by student and use all the parameters, constructors and all that particular thing. So that is the reason why it is possible for you to declare variables belonging to a particular interface also. So you can say, in fact, by saying drawable followed by D. This is allowed. drawable followed by D is allowed. You can create a variable. You can declare a variable in this particular fashion, assuming that drawable is an interface. But you cannot create the object straight away by using in this particular fashion. This is not allowed. This is not allowed because you can't create the objects out of interfaces or out of abstract classes. But you can create like what it is, objects out of subclasses of either abstract class, which is a concrete one, and that can be assigned to this particular thing. Right? So let us now go back to this particular thing, the explanation part or whatever. And you can see here drawable figure. Right? Already you know that drawable is an interface and figure is a variable. You have declared this is allowed. Remember that. And then, like, how do you create objects here? Figure is equal to, now you can't say new drawable, but you can say new line. See here, new line. This is the beauty of it. You are actually creating a line object and assigning that to drawable variable, because here, as you can see, assuming here line interface, here this is what it is. This is the assumption. Public class line implements drawable. If this is already there, so what do you mean by that? So the class line is drawable. That's what you mean by line is a drawable class. So that's why the line object can be assigned to a drawable variable. So this is allowed here. Figure is equal to new line is allowed. Now what can you do on this now? Figure dot, as we know, this figure is a drawable object, and figure dot, within the drawable interface, you have the method called draw. And this method is already implemented inside the line class. That's why when you are creating the line object has got the implemented draw method. That's why, because the figure now is containing the line object, so when you are using figure dot draw of G, it is invoking appropriate thing. Similarly, you can also say figure is equal to new filled circle, because, so just now we said filled circle is what? Filled circle implements drawable. That means filled circle, you can invoke the corresponding method safely. So that's why you can say here figure is equal to new filled circle and figure dot draw G or whatever. So these are the advantages. In fact, this is the real power of the object-oriented programming, where what we call method overriding. Method overriding is going to come into this particular picture. Right? In order to give demonstration and all that, it takes a little bit more time, because you need to write more number of classes and few interfaces and all that. It should be possible, but it takes time. So that's why let us have some theoretical background on this, and after that we will take one full-fledged class and then explain about the overall picture. Nested classes. Nested classes means a class within another class, right? That's what you mean by a class within another class. Like when you look at the actual code, you will find you will start a class, and inside that you will start another class. That means that the inside one is called as the inner class, in fact. Nested classes, right? So you can see, for example, here you can see this is the example. Public class wireframe model, curly brace begins. And then again, even before the completion of this particular class, another class is beginning here. Static public class line, curly brace begins. So this entire thing now is the inner class for the wireframe model. So this is what is called as like nested classes, a class within a class. And this is naturally local to this particular wireframe model. From outside, it won't be visible. If you want to invoke this particular thing, you will have to say wireframe model dot followed by line class. Right, as you can see here, how are you going to create the line object out of this? You can see here, new wireframe model dot line. Right. So like this, you can create the objects of inner classes by specifying the outer class name dot inner class name. So all these are possible and they have their own strength, extensions and all that. It is definitely beyond the scope of this particular subject. And these things, as just now I said, they are called as inner classes. Non-static nested classes are referred to as inner classes. So you can see here public class poker game, private class player and all that. So several different possibilities are likely to come up because of this particular thing. And sometimes you can also on the fly, you can create the objects of these interfaces and all that, right? By using this particular technique, something called new. On the fly, you can create the objects of interfaces. How do you do that? By specifying new followed by superclass or interface. See here, you can directly specify the interface name here. New interface, and then bracket begins and bracket end, curly brace begins. Implement the corresponding method here straight away on the fly. On the fly, implement the corresponding method. You can see here how he is actually creating new. As all of you are familiar, drawable is an interface. Whereas now you are trying to create a drawable object. You are trying to create an object out of interface. It's not allowed, right? But the question is, so you are implementing the corresponding method on the fly there itself. That's why it is allowed. This is called as anonymous classes. This kind of style is called as anonymous class. There is no class name, but you are having that in fact. Because unless you have a concrete class, you cannot create the object. So you are saying here drawable, red square is equal to new drawable. Look at the signature. New means like you will have to specify the interface name or a class name followed by bracket begins. That means you are invoking appropriate constructor there. And after that, because this is an interface, you can't create the objects of the interface straight away unless you implement all the methods. So that's why you are specifying here on the fly a curly brace. Curly brace begins, and then here you have to implement all the methods of this particular interface. Because there is only one method, you are implementing that here, void draw of graphics T, whatever method is there. Curly brace, do all this, do this, semicolon. It is a relatively complex thing, but you can understand. If you understand the basics, then understanding this becomes a little bit easy. Right? On the fly now you are creating. So instead of creating a class separately and then using that particular class to create the object, you are doing all that at once here, straight away. By doing new followed by interface name, bracket begin end, curly brace begins, implementation, dot. So this style is what is called as anonymous classes. They are very frequently used in Java language. Right? So straight away it can be. So whenever you require some behavior of a particular method is required, on the fly you can actually create. So this is what is called, sometimes called as on the fly you are creating the methods of the interfaces and creating objects out of them. Objects out of them. So go through these related things either through maybe any textbook that you have and all that. So essentially you need to get well versed with, right? Try to understand interface, abstract classes, and then like what it is, anonymous classes, right? Just now we said anonymous classes, and then inner classes. Inner classes will come into the nested related thing, nested classes. These are all more of a theoretical background. Once you understand properly, then you can use them while writing your programs and all that. Yes? Any questions? Okay, so just study along these topics or whatever before coming to the next class, because I will be giving an example program and give some more explanation and all that. It requires self-study also, some kind of introspection to understand these things and so on by writing programs and all such kind of things. Apart from this, like related to the packages and all that, here is one thing. There is something called static import. It is a very important thing. Like sometimes this is used in the later versions of Java and all that. So already you are familiar with import, but there is another thing called static import. The import directive, as you can see, makes it possible to refer to a class such as java.awt.color using its simple name called color. All you have to do is import java.all this or import java.awt. But still you have to use compound names to refer to static members and all that. So this is actually with respect to the classes and all that. So there is a class called math class, right? All of you are familiar with that. Math class is there that contains a number of static methods to find the square root, to find the logarithm of something, to find the maybe cube root, like that. There are so many static methods. So to import the static methods, so that without using the you call the corresponding class name and all that, the static import will be very handy. The static import will be very handy as a part of it. So you can see here import followed by static. All along we have been using import followed by straight away java.io dot or whatever and all that. Now you will be using import followed by static, then package name dot class name dot static member name, or import static package name dot class name dot star, either way. So here a simple example can be given. For example, like this, for example, you take. As all of you are familiar, system.out is an object. It is a static object actually. System.out is a static object, which is declared inside the package called java.lang. Because this is a static object and every time you want to invoke this, so you are using system.out and all that. Because only you are importing java.lang and up to that you don't have to give. But from system.out you have to give it. But you want to avoid even the system.out. You want to directly use the object itself. Only the object you want to directly use it. How are you going to handle that? So that can be done in this particular fashion. Import static java.lang.system.out or import static java.lang.math.star. Right? Math.star. So once you do this, a simple example probably is likely to give it. No, so he's not giving any example of that particular kind, but straight away the advantage of that is that you can straight away start using it. So as we can see, instead of calling like math.log, you can invoke log itself straight away. Directly it is available in the form of log instead of saying math.log. When you say import static, even math dot also need not be given. If static is removed, then you can only invoke math dot square root, math dot log, and all that particular thing. Right? So that is the use of the static, which you just simply write a small program. You will get to know about the corresponding thing. right? So for the next class, when you come with some preparation along these lines, and I will try to give some example code so that you can actually look at it. So in today's session, if you have any questions on any of these things, we can discuss. Otherwise, I would like to wind up at this particular stage because taking up those programs will take a lot of time. It is beyond our timings what we have right now. Okay, so if you have any specific things, we can discuss. Otherwise, I would like to close the session. Start writing the code, programs and all that so that you'll be comfortable.